These are the Sparkboxes. And it's a 1-bedroom, 1-bath that drops into your backyard, sets up in 4 hours, and is completely off-grid. There's 12,000 watts of panels on the roof, of solar panels. There's 1,250 gallons of water storage and 330 gallons of gray water that you can use for landscaping. So it needs no utility connections at all. So the idea is that if you drop this in your backyard, and the 1,250 gallons is based on one person for 2 months or 2 people for a month. And so that, to me, seemed like a very easy solution to, I'm gonna fill that with my hose, then trenching my yard, putting in a new water service, and bringing out to it. Okay, so these are the Sparkboxes. So let's go inside and I'll show you. So when this dropped into your backyard, it has full service, so you don't need to set up an electrical service in order to live in it. Your main bedroom space here, you have a kitchenette with a refrigerator, and then the bathroom here. Everything here is being run off of battery and solar. This is our smaller bathroom. This is the Cinderella, which is an amazing incinerating toilet. We tested it for many months inside of our factory and to see what the smell was like. That I didn't want a composting toilet. So the only difference is you have to use this liner, which I call the coffee filter. And so this goes in, and that's it.
And then because that keeps it clean inside.
Right.
So
if you don't use that, it's a mess.
And that goes down, and then it all
goes
gets
down
burnt.
And is smoldered, yeah. Every 100 flushes, you empty out the ashtray, depending on how much you eat.
The ashtray, where's the ashtray?
So the ashtray is here.
Because it's similar to emptying an ashtray, I guess.
It's literally, you pull it out and it's literally gray ash. This is the ashtray. So you can see it pulls out from below. Yeah. It saves 2,000 gallons of water per person per year. So there's no water connection at all.
The idea that you're burning up all your waste, is that a lot of energy? I mean, you really can stay off grid and manage that.
So it does use 2,000 watts, and it depends on how much you are burning. If you're going to push the flush button, because it's an electric toilet, 14 times, and if it burns for an hour, obviously you're going to be using a lot of energy. In this particular unit, we have 25 kilowatt hour of battery storage. You're going to use 2 kilowatt hours every time you flush the toilet, which during the day is not an issue. But if you have 30 kilowatt hours at night and you had something that didn't sit well, you really don't want to flush the toilet 15 times.
But you can leave it there.
You can leave it.
And it won't smell because it gets trapped underneath. Okay.
You can leave it.
You can wait and do it in the day. And here you see the layout that they're staggered.
Yes.
Right? So there's the same hole in the back then?
So we have a 20-foot segment in front and a 30-foot segment in back. What's driving that is to have enough for water storage in the back. So this is our tank room.
So this is what it comes with. This is how many gallons of water?
So this is 1,250 gallons in the back.
Okay.
This is your gray water tank right here, which is 330 gallons. And you have 1,250 gallons in the back. And so that comes through, when you fill that with your hose, it comes through this UV light filter and through the 50 to 5 micron filter. This is your expansion tank for pressure. And then it's pumped into the unit. This is your water heater, which is an 8-gallon water heater. I call it a sustainable shower.
So this water, so it comes empty, and then you just plug in a hose or...
This is where the water goes in and out. So this is a quick release right here. So this is how you fill it. You attach your hose to this and it locks in place. And then you can have water in and water out. So if I need water in the yard and I need some pressure on a hose, I can connect my hose to the outside of this, and now I have a hose to use in the yard if I want.
That could be gray water too?
So the gray water comes out the nozzle over here, which I'll show you. This on the floor right here is a grease interceptor. That comes from the kitchen. That goes through it to the gray water. So it cleans anything from the kitchen area if there is some sort of fat that gets in there. or oil, it will go through that before it goes through this filter. On the way out, it goes through another 55 micron filter. So this is going to remove all of the hair and soap and everything from the shower and sinks before it goes into your gray water tank. And then this allows you to let it either drain into the landscape, or there's a valve underneath here, which you can hook up another system to your irrigation system. So you can use that 330 gallons. So you're not wasting any of the water that you're using here.
You could even have a timer for sprinkling or whatever it is.
Exactly. So when you think about it, there's no black water created because the toilet is incinerating. The two sinks that we have in the shower all pump into here. And so we basically have created a sustainable RV that doesn't go anywhere. That's permitted. It's almost hard to explain how the adoption of something like this is so different for people. Like, to understand that in one day, this could be in your backyard. In one day. And people who have been through a construction process understand that a little bit more.
Do you have these models built in factory? Can they be transported the way they are, like finished?
Yes, we just put this here 2 weeks ago. Yeah.
So no cracks, no.
I mean, everything is panelized so that it's designed to move. This panel that you can see is loose here. This is what goes on once we drop it at what they call the marriage line to join the two units together. So it's designed for a backyard. So technically, we just passed the ADU legislation here in Phoenix. Cooking is what makes it a dwelling unit. So when these were created, we had not passed the ADU legislation. And so there is no cooking. There is a dedicated circuit for any type of small appliance. The details matter and how materials come together matter. From a manufacturing standpoint, the gaps and things are there so that there is some movement. So when it is shipped, we're not dealing with a bunch of cracking. The clean way I felt to do the electrical recept is to put it in the base like that. And so I think anywhere that the material comes together, this actually is a light shaft here down the center. And so to use that as an opportunity, as a feature versus just where the unit comes together. And then again here, this is the return air. This is a ducted mini split. Did you get that? And then all your return air comes through here and your supply out the Seho vents. And they allow you to really diffuse down the amount of air and direct. And so it's a really good feature. Say you're in bed and you want to have more air in a specific direction. This, if you want the Murphy bed, or if you want a bed that it turns into a sofa Murphy bed, and all of your services are back in these service doors here. And so we have our ducted mini split here, and then our battery storage, which this is showing 25 kilowatt hours of battery.
And the expense of putting in this much solar, is it?
The batteries are probably the most expensive part of it. So, solar panels are such a commodity now, it's really not driving the price. But you have to compare it to what it would cost to install it all from an electrical standpoint in your backyard, what it means to have contractors in your backyard all the time, dealing with an architect, getting the permits, versus one day of us bringing this in and setting it down.
Because if it's off-grid, it changes the permitting process?
No, it doesn't change the permitting process, but because this is a prefab factory-built building, the drawings are already approved. If you're going to build an ADU in your backyard, ground up, that's a much longer process. You're tying into your electric. And so when you think about from a pricing standpoint, you don't ever have another electric bill here. These two are early prototypes. This was before we actually extended the solar panels off of the top. So when a container shows up on the truck, there's no room to pick it up with forks. And we don't buy boxes with fork pockets because it takes the structural capacity out of that box quite a bit. And so in Phoenix, to get what's called a reach stacker, which is what you see in the ports that pick them up from the top, would be about $500,000. And so we built this jig, which goes over the container. These chains in the corners attach to each end, and then we lift the box.
That's Mad Max grade type of.
When you're innovating on a small budget, it's a really great solution. So the container's picked up with that forklift. and it's brought over onto this rail. Right now the rail is wrapped for foaming. So when we spray foam underneath the container, it's put on this rail. The container puts on here, and then it rolls inside for manufacturing.
It's a slightly different texture.
These are the casters that we created for the containers to roll on. So each one of these, you can see the container fits on the end of here and allows it to roll. So the container comes in, it gets locked in at this point with that jig so that it's in the same place every time. And then it gets cut by the robot. We pulled this robot out of Mercedes in Detroit and then repurposed it to cut the shipping containers. Cutting the containers is really hard work, and the containers are intentioned so it pinches your blade, and this ability with a large 14-inch blade allows you to, boxes can move. If it pinches the blade, then there's a torque sensor that allows it to know that, hey, I'm getting pinched, pulls out of the container, and then goes back into the code and goes back into the program based on what we've drawn. There's going to be another robot and that's going to sandblast the container. So the container will be on a chain system and it will index to each location. The robot will sandblast the paint off and then it will move again to the next location. From a manufacturing standpoint, this is a really great way to do that and will cost a third of what it costs for me to have someone out here to sandblast it. So what happens is that carrier comes down and you take this tool and the container sits on the end of here, the corner nodes sit on here. And this allows us to basically turn the direction in order for it to change direction.
So this way would be going from the...
Right, so I turn this, so now if we come from the robot, you know, this would be coming this direction from the robot. It would come down and the container's on here, and then I would turn it like this. Now we can go this way, right? So it's very...
And send it out to be shipped out.
And then we can, well, then it goes down to the other side of the robot, so we can cut the other side of the container. And so it's a really simple system that allows us to just turn that node.
Because you're trying to get things at scale.
Yeah, I'm trying to make it as efficient as possible so that we can bring costs down overall. By going with a lean manufacturing process, we're able to increase the amount of output dramatically. We'll easily be able to double what we can produce by doing that. So this is where all of the wall panels are cut on the CNC machine. This gives us the ability to not wait on a shop to deliver those wall panels. So it's really important that we're able to control the flow here on site with as many things as possible. One of the things that was holding us up is the spray foam. And so we decided to bite the bullet and go and do the spray foaming on site.
Wow, so you're really doing all the verticals.
We're trying to. We're pretty close to everything. One thing you can take note here is these are freshly sandblasted.
And you need to do that? Is there a reason?
Well, that's the only way it will rust.
Oh, okay.
It's the only way it will patina.
Yeah, you see that they're rusted already. Like that just starts to happen, no?
Yeah, we don't apply anything to it.
Yeah, it just does this.
It's Mother Nature. Yeah, and so this is one of my favorite parts. This is a hot rolled steel panel. And these marks on here are from the milling process. So when it comes through that furnace and is rolled, you get the remnants of that heat. And so you can really see the processes of it being made. And now we've put it here and put a sealer on it as the backsplash, which I just love. Here's another burn mark, like this burn mark here with a little bit of color in it. You can kind of see the clip system here. So this panel, so when these come together, we foam the gap, and then this panel goes and clips on. If you see the back side of this, one's male and one's female, and it clips on. And so it allows us to have a great system without fasteners being seen. But the really challenging part of this is that you can see these are epoxied in, And this location is really important to align with the other side of it. And so this has to be CNC'd, and the hole where that side goes has to be CNC'd. And so you can see here from a production standpoint, this panel is PB, and this is here's the arrow that goes up. And so all of that is CNC'd into the panel for production. Because we're manufacturing these, we have a decal that is put on the box from the state. And that serial number is registered with the state as a box, which provides the wind load and snow load of the box. So the intent there is that you have a way to track that product. So if somebody buys this and wants to take it to Colorado, the snow load requirements in Colorado are different than they are in Arizona. So we have to have a serial number that goes with it. So this is J and this is PB, PB and J. This unit here, we are creating office space to go in your backyard. This is a 20-foot container. It comes with a beverage fridge and cabinetry. I was thinking that if you're going to use this as an office, it would be nice to just include a beverage fridge and some storage on top of that. And so then we've provided a plug and USB and USB-C in the back. So it's all integrated. And the idea here is that these panels all have a CNC file, right? So they all get cut on the CNC machine. And you know panel A always goes here and panel B always goes here. And so it allows you to produce this in a much faster way. All of the utilities is integrated. So your air is coming out of here from the heat pump. And then your return air is here through this side. Drops down the wall into the mechanical closet and then back through. And so it's a really nice clean detail instead of having a mini split cassette hanging on the wall.
So despite the amount of glass you have here and the dimensions and the fact that the encasing is metal, is this Arizona proof?
Oh yeah, it's phenomenally efficient.
Even solar glass, right?
Yes, so this is a Solar Band 70 XL. You know, it does a great job, especially in the summer when our sun is at 89 degrees. The solar panels that overhang shade the glass.
And how much do you worry? I mean, it's a shipping container, so it's metal. People always talk about like, oh, it's gonna get hot.
Right. The steel container gets hot, but it releases that heat very quickly, and that's one of the things we always deal with in Arizona is that latent heat or the heat island effect. And actually having a concrete tile roof and all of the pavement in our city is really adding to that heat island effect where steel, what conducts heat very quickly, releases it very quickly. The heat is on in here.
Heat.
Because we've been running some tests. One of the really interesting tests that we did last winter was we set it to 88 degrees. We left the windows and doors open and it was using about 3,000 watts. We closed the doors and windows and it was 45 degrees outside. All night long it was 400 watts of use and it was 88 degrees inside the unit. So it's really amazing. I don't know if you want to see the behind the scenes on this one. This was much tougher to integrate. It takes a lot of work to get a small space to be off grid, right? Our 2 lithium batteries here. Right now we're using 268 watts and we're bringing in 1,289 watts. So 1 kilowatt we're bringing in and our batteries are at 85% right now.
So you're looking good, basically.
Yeah, so by the time the sun sets, we'll be no problem, be covered. The reason that this battery is low is because we're doing some testing with the heat. So at night, we crank it all the way up. This is the return air. So that air that I was showing you on the inside comes in, comes down the wall, out, and when it's cold air, it's cooling the equipment, and then going back into your ducted mini split.
So you're basically creating, it's a vertical product like Apple in the sense that you're controlling the software and the hardware.
Yeah, I mean, as many things as we can do within the sequence of manufacturing, we're able to control the quality, the timeline of it being built. And so there's benefits for us to do as much as we can. There we go.